Hey, Sophie Analyze the Math Industry, and we're going to be reviewing simplifying the square roots. So, you probably know or have learned about what a square root is. So when you see the square root symbol, it tells you what two numbers could be multiplied into that number. Under the square root symbol is called the radicand, because the word radical in mathematics means the root of a tree in Latin. So, if we're calculating the square roots of that, we're trying to find what two numbers, or just what number, can be multiplied by itself 2 times to get to that. Here's an example. My favorite one is find the square root of 16. Well, what we can do about that is 4 times 4 is equal to 16. So, the square root of 16 should equal 4. However, sometimes perfect square roots are not always going to happen. And other times, you have to do like the square root of 20. But how can we do that? How can we simplify that? Well, what we could do is we can't really square root that because that will be a long irrational decimal. Decimals that keep going forever and ever and ever and ever and ever and ever and ever and ever.
A few moments later, 1 eternity later, 3 days later,
and ever and ever and ever and ever and ever and ever and ever. So what we don't want to do is have a number that keeps going forever and ever. What we can do is we can pull out the 20 into some different numbers so we can simplify it to its simplest form. Here's an example. We can multiply 4 and 5 that both go into 20. So, since 4 is a perfect square, we can transform it into the number 2. What we have to do is try and get to the most simplest form. So we move that 2 to the top. And now we have 2 to the square root of 5. The 5 because we have never ever used it before. And this is its most simplest form. But hang on, why does it have to be 4 and 5? Why can't we redo the same problem as the square root of 20 and say 2 and 10? This combination is not going to work because 2 is not a perfect square and 10 is not a perfect square. When you try to find the perfect pairs, try to find the largest number by combination, and also try and find a number that can be squared. Let's try that with another example. Let's try and do 2 the square root of 48. Well, what we could use is 4 and 12 are good pairs to start out with. Since 4 being the perfect square root, we transform it to 2. But we still have another number in front of the square root. And we still have that 2 that we have transformed to pull out. So we have to turn this into a new number. 4 the square root of 12. But we're not done yet, because 12 can be simplified too. If you don't use combinations that have a square and the biggest possible number, you will have to do the process again. Here's an example. 4 and 3 both multiply into 12. What we can do, circle the 4, transform it into a 2, multiply that with the number that was already in front of the square root. So now we have 6, the square root of 3. That is the same thing and the most simplest form of 2, the square root of 48. And that is how we can simplify the square roots when they are perfect and non-perfect. I hope this video has helped you. Thank you for watching Tao Ping Analyze Math Industry. like and subscribe.